Hi friends, this is Chetanadde, working as an assistant professor in MIT College of Railway Engineering Research, Barshi. This is our fifth video on the topic of Fourier series. What we have to do in this video, we have to find the Fourier series expansion in minus L to L. Okay, minus L to L ह्या रेंज मध्ये आपल्याला Fourier सिरीजचं फंक्शनचं एक्सपान्शन बघायचं. ठीक आहे, जेव्हा आपण ही सिरीज डील करणार आहे, पहिल्या व्हिडिओमध्ये आपण बेसिक डेफिनेशन बघितली, दुसऱ्या व्हिडिओमध्ये आपण 0 to 2 पाय, त्यानंतर -पाय टू पाय, त्यानंतर 0 to 2l असे एकूण आपण 4 व्हिडिओ बघितले इथपर्यंत. आणि आता या व्हिडिओमध्ये आपण -L to L ही रेंज बघणार. जेव्हा आपण 0 to 2 पाय ही रेंज बघितली तेव्हा आपल्याला त्याच्यामध्ये कुठलेही काय रिस्ट्रिक्शन नव्हतं, पण जेव्हा आपण -पाय टू पाय ही रेंज पाहिली त्या रेंज मध्ये आपण 3 टाइपचे फंक्शन बघितले. ते फंक्शन इवन नाहीये, ऑड नाहीये, ते फंक्शन इवन आहे आणि ते ऑड आहे. ठीक आहे, तिसऱ्या व्हिडिओमध्ये आपण पाहिलं होतं ते. सिमिलरली ह्या व्हिडिओमध्ये जेव्हा माझी रेंज -L to L आहे, सेम ह्या व्हिडिओमध्ये आपल्याला त्या कंडिशन एक्झिस्ट होणार आहेत. काय ते फंक्शन, पहिली कंडिशन, ह्या रेंज मध्ये एकूण 3 कंडिशन आहेत. पहिली कंडिशन काय की ते फंक्शन इवन आणि ऑड दोन्ही सुद्धा नाहीये. दुसरी कंडिशन काय की ते फंक्शन माझं इवन आहे. आणि तिसरी कंडिशन काय माझी, ठीक फंक्शन काय माझं ऑड आहे. ओके, मग ज्यावेळेस माझं फंक्शन इवन पण नाहीये आणि ऑड पण नाहीये त्या केसमध्ये काय मला फॉर्म्युला आहे. ज्यावेळेस माझं फंक्शन इवन आहे त्यावेळेस माझा फॉर्म्युला काय आहे, ज्यावेळेस माझं फंक्शन ऑड आहे त्यावेळेस माझा फॉर्म्युला काय आहे, हे आपल्याला 1 by 1 बघायचं. ठीक आहे, त्यावेळेस पहिल्यांदा बघूया आपण की माझं फंक्शन इवन पण नाहीये आणि ऑड पण नाहीये. इन दॅट कंडिशन वी हॅव टू फॉर्म्युला f of x is equal to like that in this interval 0, 2l मध्ये जे काही फंक्शनचं फॉर्म्युला होतं ॲज इट इज असणार. f of x is equal to a naught plus summation n running from 1 to infinity an into cos n pi by l x plus summation n running from 1 to infinity bn sin n pi by l x. ठीक आहे, हे आपलं एक्सपान्शन झालं. मग a naught ची व्हॅल्यू काय, a naught is equal to 1/2l minus L to L f of x into dx. Again this an is equal to 1 by l minus L to L f of x into cos n pi by l x into dx, and bn is equal to 1 by l minus L to L f of x into sin n pi by l x dx. ओके, जर माझं फंक्शन इवन पण नाही ऑड पण नाही तेव्हा माझा हा फॉर्म्युला. जेव्हा माझं फंक्शन इवन आहे तेव्हा काय माझं एक्सपान्शन. इन दॅट कंडिशन जेव्हा माझं इवन फंक्शन आहे त्यावेळेस माझी bn ची व्हॅल्यू काय असणार आहे, 0. म्हणजे ह्या एक्सपान्शन मध्ये काय येणार आहे, फक्त a naught आणि an ह्या दोनच व्हॅल्यू येणार. f of x is equal to a naught plus summation n running from 1 to infinity an into cos n pi by l x, where a naught is equal to 1 by l 0 to l f of x into dx, and an is equal to 2 by l 0 to l f of x into cos n pi by l x dx. म्हणजे bn ची व्हॅल्यू काय झाली माझी 0 झाली जेव्हा माझं फंक्शन इवन आहे त्यावेळेस. आणि जेव्हा माझं फंक्शन ऑड आहे त्यावेळेस माझी a naught आणि an ची व्हॅल्यू काय असणार आहे, 0. म्हणजे त्या कंडिशन मध्ये जेव्हा माझं फंक्शन ऑड आहे त्यावेळेस मला फक्त आणि फक्त bn चीच व्हॅल्यू फाइंड करायची. आणि त्याचं एक्सपान्शन कसं असणार आहे, f of x is equal to summation n running from 1 to infinity bn into sin n pi by l x dx. Okay, where bn is equal to 2 by l integration 0 to l f of x into sin n pi by l x dx. Okay, at that time the value of a naught and an is 0. We'll see one by one example on this article. Now this is our first example on the -L to L. Find the Fourier series expansion of f of x is equal to x, where x belongs to -5 to 5. म्हणजे ही रेंज दिली आपल्याला, काय रेंज त्याची, -5 to 5. म्हणजे l ची व्हॅल्यू काय झाली तर माझी 5 झाली. फंक्शन कुठले दिले माझं, f of x is equal to x. ज्यावेळेस माझी रेंज असली -L to L किंवा -पाय टू पाय, ह्या रेंज मध्ये आपण चेक काय करायचं की ते माझं फंक्शन इवन आहे का, ऑड आहे का, किंवा इवन पण नाही ऑड पण नाही, हे आपण सगळ्यात पहिल्यांदा चेक करायचं. आणि पहिल्या व्हिडिओमध्ये मी तुम्हाला सांगितलं की फंक्शन इवन आहे का, ऑड आहे का नाही ते कसं चेक करायचं ते पहिल्या व्हिडिओमध्ये आपण बेसिक डेफिनेशन मध्ये पाहिलेलं आहे आपण. ठीक आहे, मग ह्या फंक्शन मध्ये काय करणार आपण, f of x is equal to x. वी नो दॅट दिस फंक्शन इज ऑड फंक्शन. ठीक आहे, आणि ते सुद्धा आपण आता फॉर्म्युल्यामध्ये बघितलं होतं की जे जर फंक्शन माझं ऑड असेल आणि जर त्याची रेंज -L to L किंवा -पाय टू पाय असेल तर त्यावेळेस माझं सिरीजचं एक्सपान्शन काय असतं, f of x is equal to summation n running from 1 to infinity bn into sin n pi divided by l into x. हे माझं त्या सिरीजचं एक्सपान्शन असतं. ठीक आहे, आणि ह्या केसमध्ये मला bn फाइंड करावं लागतं. मग काय माझा bn चा फॉर्म्युला, वेअर bn इज इक्वल टू 2/l इंटिग्रेशन 0 to l f of x into sin n pi divided by l x into dx. This is our formula. Okay, now we know that the value of l, by comparing we will get the value of l is equal to 5. Put this value in this integration in the place of l and find this value of integration. We know that the value of f of x also, what is that value, x integration 2 divided by 5 integration 0 to 5. Now this f of x is x into sin n pi divided by 5 x into dx. Now by using Liet rule, this x is my first function and this is my second function, and now by using rule of integration of u into v is nothing but first function as it is integration of second minus, which is equal to, by using that rule, this 2/5 as it is first function as it is into integration of second n pi divided by 5 into x into dx minus integration of derivative of first d by dx of x into integration of sin n pi divided by 5 x into dx. Okay, which is equal to this 2/5 as it is. इंटिग्रेशन मध्ये आपण कॉन्स्टंट काय करतो, डिवाइड करत असतो. दिस x is also as it is. Now what is the integration of sin minus cos? Okay, minus of cos n pi divided by 5 into x divided by n pi divided by 5. Okay, हा एवढा काय माझं कॉन्स्टंट आहे. इंटिग्रेशन मध्ये आपण कॉन्स्टंट काय करत असतो, डिवाइड करत असतो, म्हणून इथे मी कॉन्स्टंट डिवाइड केले. ओके, minus integration of what is the derivative of x is 1, and again the integration of sin is minus cos, minus this is become plus cos n pi divided by 5 into x divided by n pi by 5 into dx. Now this n pi by 5 is constant, we can take outside the integration. Okay, and this denominator चा denominator म्हणजे उलटून कुठे जाणार आहे, न्यूमरेटरला, which is equal to 2/5 in this bracket. हा कॉन्स्टंट आहे, डिनोमिनेटर चा डिनोमिनेटर उलटून न्यूमरेटरला minus 5x divided by n pi into cos of n pi by 5 into x plus, now this have constant denominator to denominator root to numerator la. Okay, this 5 divided by n pi into integration of cos n pi by 5 x into dx. This bracket complete, which is equal to, now this 2/5 is also as it is. Now again this 2/5 as it is in this bracket minus of 5x divided by n pi into cos of n pi divided by 5 into x plus this 5 divided by n pi as it is. And now we know that what is the integration of cos sin n pi divided by 5 into x divided by n pi divided by 5. This bracket complete. परत डिनोमिनेटर चा डिनोमिनेटर रूट न्यूमरेटरला ह्या दोघांचं मल्टिप्लिकेशन ह्याच्या बरोबर, ह्याचं मल्टिप्लिकेशन ह्याच्या बरोबर, which is equal to this 2/5 in this bracket minus 5x divided by n pi into cos of n pi divided by 5 into x plus this 5 into 5 is 25 divided by n square pi square into sin of n pi divided by 5 into x. And what is the limiting value here? Integrating value is 0 to 5. Now this lower limit is 0 and upper limit is 5. Put this value in this value of 2/5 as it is. Now upper limit is 5 and lower limit is 0. Now put here, now this 5 into 5, जिथे जिथे x दिसतंय तिथे काय पुट करणार मी, 5 पुट करणार. 5 into 5 25 divided by n pi into this cos of n pi divided by 5 into 5 plus 25 upon n square pi square into sin of n pi divided by 5 into 5. This is my upper limit minus what is the value of lower limit. इथे 0 पुट करणार मी, तेव्हा ही सगळी व्हॅल्यू माझी 0 होऊन जाणार, आणि इथे सुद्धा sin 0 ची व्हॅल्यू काय होणार आहे, 0. म्हणजे लोअर लिमिट काय येते माझं 0, which is equal to, now this 5 cancel with this 5, again this 5 cancel with this 5, Now this we know that the value of cos n pi is minus 1 to the power n, and sin n pi is 0, and this lower limit is obviously 0, which is equal to this 2 by 5 in this bracket minus of 25 divided by n pi into this cos n pi is minus 1 to the power n, and this total value is 0. Okay, now this 5 cancel with this 25, this 5 into 5 is 25, this 5 into 2 is 10, which is equal to minus 10 into minus 1 to the power n divided by n pi. This is the value of Bn. Okay, now Bn is equal to minus 10 into minus 1 to the power n divided by n pi. Okay, this is value of Bn. Now put this value of Bn in this expansion, we will get the Fourier series expansion of this x in the range minus 5 to 5. Okay, this is a very simple example. We will see one more example. Now once again, here is a very simple example of this type minus L to L, which is nothing but find the Fourier series expansion of f of x is equal to x square, which is very simple example is there. We know that this f of x is equal to x square is an even function. If the function is even, at that time the value of Bn is 0. Means we have to find the value of only a0 and Al. The Fourier series expansion is given by f of x is equal to a0 plus summation n running from 1 to infinity an into cos of n pi divided by L into x. जेव्हा आपल्याला एक्झाम मध्ये एक्झाम्पल येतं अशा टाइपचं, त्यावेळेस हा सिरीजचं एक्सपान्शन लिहायला 1 मार्क असतो सुरुवातीला. ठीक आहे, त्याच्यामुळे हे सिरीजचं पहिल्यांदा एक्सपान्शन लिहिणं मस्ट आहे. ओके, नाउ वी हैव टू फाइंड द वैल्यू ऑफ a0. वी नो दैट द a0 इज इक्वल टू, व्हाट इज द फॉर्मूला, 1 by L into integration 0 to L f of x into dx. This is a formula. Okay, which is equal to value of L is 1. By comparing we will get the value of L is 1, integration 0 to 1. What is the value of f of x here? X square into dx, which is equal to, what is the integration of x square? X cube divided by 3, and the limiting value is 0 to 1. Now by putting upper limit minus lower limit, we will get a0 is equal to 1 by 3. This is value of a0. We have to find the value of an. Now an is equal to, what is the formula? 2 by L integration 0 to L f of x into cos n pi by L, n pi divided by L x into dx. Again we know that the value of L is 1, and also the value of f of x is x square. Put both the value in this integration. 2 into integration 0 to 1 x square into cos n pi x into dx. Now for finding this integration, use that Liet rule first. On that rule, first of all decide this is first function, this is my second function, and now using the rule of integration product rule, we'll get 2 into, in this bracket, function as it is, into integration of n pi x dx minus integration of d by dx of x square into integration of cos n pi x into dx. This bracket is complete. Again this dx and this whole bracket is complete. Okay, which is equal to this 2 as it is, this x square is also as it is, into what is the integration of cos sin n pi x divided by n pi minus the integration of day root of x square is 2x. Okay, this 2x into what is the integration of cos sin n pi x divided by n pi, कारण की इंटिग्रेशन मध्ये आपण कांस्टेंट काय करत असतो, डिवाइड करत असतो, which is equal to this 2 as it is in this bracket x square into sin n pi x divided by n pi, and this minus 2 upon n pi is constant, integrating constant, that's why taking outside the integration this 2 by n pi, and this integration of x into sin n pi x into dx. Now for finding this again integration, use that product rule of integration, which is equal to 2 in this bracket x square into sin n pi x divided by n pi, minus of 2 upon n pi in this bracket. Now this is my first function, this is my second function. Use the integrating product rule of integration. We'll get this first function as it is into integration of sin n pi x dx minus integration of d by dx of x into integration of sin n pi x. This bracket complete, which is equal to this 2 as it is in this bracket x square into sin n pi x divided by n pi minus 2 upon n pi. Now this in this bracket x as it is. Again we know that the integration of sin is minus cos, and that constant divide to that minus cos, minus of cos n pi x divided by n pi. It's very simple. Minus of integration of derivative of x is 1, and the integration of sin is minus cos, minus minus this will becomes plus cos n pi x divided by n pi into dx. This whole bracket complete, which is equal to this 2 as it is in this bracket x square into sin n pi x divided by n pi minus 2 upon n pi in this bracket minus x into cos n pi x divided by n pi. Now what is the integration of cos sin n pi divided by n pi? N square pi square plus of sin n pi x divided by n square pi square. Okay, now we have to multiply. Now multiply this term to this bracket, we will get, which is equal to this 2 as it is in this bracket x square into sin n pi by x divided by n pi. Now multiply this term to this bracket, minus minus this is become plus 2x into cos n pi x into n pi n square pi square. Now this plus becomes minus due to this term, minus of 2 into sin n pi x divided by n square pi square into this n pi. This is nothing but n cube pi cube, and limiting value is 0 to 1. Now put upper limit minus lower limit in this term, we will get this 2 as it is. By putting this value of upper limit 1 in the place of x, we will get 1 square is again 1. This sin n pi जिथे जिथे x दिसते तिथे मी व्हॅल्यू पुट किती पुट करणार 1. 1 स्क्वेअर किती झाला 1. परत इथे 1 पुट केलं म्हणजे इथे किती झाला sin n pi डिवाइडेड बाय n pi प्लस अगेन इथे 1 पुट करणार 2 into इथे किती येणार आहे cos n pi डिवाइडेड बाय n स्क्वेअर pi स्क्वेअर मायनस ऑफ 2 into परत इथे मी पुट करणार किती पुट करणार x च्या ठिकाणी 1. हे किती येणार आहे sin n pi divided by n cube pi cube. This is my upper limit. Again my lower limit is minus lower limit. इथे x दिसते इथे पुट केलं व्हॅल्यू झाली 0 म्हणजे ही व्हॅल्यू 0. परत इथे सुद्धा x दिसते म्हणून ही व्हॅल्यू किती झाली 0. परत इथे व्हॅल्यू किती येणार आहे sin 0. We know that this value is also 0. 0 plus 0 minus 0 means our lower limit is 0, which is equal to this 2 into this. Also we know that the sin n pi is 0. Again this sin n pi is also 0, and this cos n pi is minus 1 to the power n. This 2 into minus 1 to the power n divided by n square pi square. That's why the value of an is equal to this 2 into 2 is nothing but 4 into minus 1 to the power n divided by n square pi square. This is the value of an. Now put the value of a naught and an in the expansion of f of x is equal to a naught plus summation n running from 1 to infinity an into cos n pi by l x. Okay, we know that the value of n is 1, a naught is 1 by 3, and an is here, which is equal to 1 by 3 plus summation n running from 1 to infinity. A naught is 4 into minus 1 to the power n divided by n square pi square into cos n pi x. This is the Fourier series expansion of f of x is equal to x square in a range minus 1 to 1, which is very very simple. So very simple examples are there. We'll see one more. Now this is our third example, which is nothing but find the Fourier series expansion of f of x is equal to e raised to ax, x belongs to -1 to 1. आता जे काही फंक्शन दिलं, जेव्हा माझी अशी रेंज असते तेव्हा मी तुम्हाला सांगितलं की पहिल्यांदा आपल्याला चेक करायचंय हे फंक्शन इवन आहे का, ऑड आहे का, किंवा इवन पण नाहीये आणि ऑड पण नाहीये. we know that this function is not even and not odd. That's why the Fourier series expansion is given by f of x is equal to a naught plus summation n running from 1 to infinity a n into cos n pi divided by l x plus summation n running from 1 to infinity bn into sin n pi divided by l x. Okay, this is our expansion. Now find the value of a naught, a n and b n. Now a naught is equal to 1 upon 2l integration minus l to l f of x into dx, which is equal to this 1 upon 2. What is the value of l here? 1. Integration minus 1 to 1. What is the value of f of x? E raised to ax into dx, which is equal to this 1/2 as it is. What is the integration of e raised to ax? This e raised to ax upon a, and the limiting value is -1 to 1. Limiting value कुठे पुट करणार आपण, जिथे जिथे x दिसते तिथं, which is equal to this 1/2 as it is in the bracket e to the power a divided by a minus e to the power minus a divided by a. Okay, this upper limit minus lower limit whose base is same, म्हणजे घातांकाचा बरोबर आपण डायरेक्टली सबट्रॅक्शन करू शकतो, which is equal to now this 1/2 as it is in this bracket e to the power a minus of e to the power minus a divided by e. This is our value of a naught. Therefore a naught is equal to e to the power a minus of e to the power minus a divided by 2a. This is value of a naught. Now we have to find the next value of an. An is equal to 1 upon l integration minus l to l f of x into cos n pi divided by l into x into dx. Now what is the value of l here? 1. And what was the value of f of x is e raised to ax. Put the both value, which is equal to -1 to 1, because 1 divided by 1 is 1. What is the value of f of x? E raised to ax into cos n pi, because the value of l is 1, x into dx. Now for finding this integration we have an formula here. It's e raised to ax into cos bx into dx, which is equal to e to the power ax divided by a square plus b square, a cos bx plus b sin bx. It's very simple formula is there. Now here a is a and the value of b is n pi. Put both the value in this formula, we will get our required integration, which is equal to this e raised to ax divided by a square plus what is the value of b? N pi bracket square. In this bracket a cos bx means a into cos n pi x plus b into means n pi into sin n pi x. This is our simple integration is there. Now put the upper limit minus lower limit in this value, which is nothing but upper limit is 1 and lower limit is -1, which is equal to e to the power a divided by a square plus n square pi square. This is my whole bracket. In this simple bracket, in a cos n pi plus n pi into sin n pi, upper limit is there, minus lower limit is e to the power minus a divided by a square n square pi square. In this bracket a cos minus n pi plus n pi into sin of minus n pi, whole bracket complete. Now we know that the value of this, which is equal to this in this bracket e to the power a divided by a square plus n square pi square as it is. In this bracket this a is also as it is. What is the value of cos n pi? -1 to the power n minus 1 to the power n plus sin n pi 0 into this n pi again 0. That's why here is only one value is there. Okay, minus of this value e to the power minus a divided by a square plus n square pi square. Again in this bracket a into cos minus n pi is also minus 1 to the power n, and this value n pi into sin minus n pi now get 0. That's why here is only value is there. This which is equal to this e to the this value are which is nothing but e to the power a into e to the power a into minus 1 to the power n divided by a square plus n square pi square minus of a into e to the power minus a into minus 1 to the power n divided by a square plus n square pi square. Now an is equal now from this term a minus 1 to the power n, this a square plus n square pi square is common terms. That's why we can take common, which is equal to a into minus 1 to the power n divided by a square plus n square pi square is taking common, and in this bracket e to the power a minus of e to the power minus a is in this bracket. That's why this is my value of an, which is very simple. Okay. Similarly, find the value of bn. Now we know that bn is equal to 1 upon L integration minus L to L f of x into sin n pi divided by L x into dx. Now put the value of L and f of x in this integration. We will get integration minus 1 to 1 e raised to ax into sin n pi x into dx. Now for finding this integration, we know that here is formula. For finding this integration, here is formula. Here the value of a is same and the value of b is n pi. Apply this formula here, which is equal to this e raised to ax plus divided by a square plus n pi bracket square, because this is value of b. Okay, in this bracket a sin n pi minus n pi into cos of n pi x. Okay, and this lower limit is minus 1, upper limit is 1. Put this value for finding the upper limit and lower limit. We will get which is equal to in this bracket. Now upper limit is e to the power a divided by a square plus n square pi square. In this bracket a sin n pi minus of n pi into cos of n pi, bracket complete. This is my upper limit minus of, now here is lower limit is there because the value of x is minus e to the power minus a divided by a square plus n square pi square. In this bracket a into sin of minus n pi minus of n pi into cos of minus n pi. This bracket complete, this complete, and this is again complete, which is equal to in this bracket e to the power a as it is divided by a square plus n square pi square. In this bracket we know that the sin n pi is 0, cos n pi is minus 1 to the power n. That's why this value is 0. Here is minus sign is there, minus of n pi into minus 1 to the power n. This bracket is complete, minus here e to the power minus a divided by a square plus n square pi square is there. In this bracket again we know that sin of minus n pi is 0 and this cos of minus n pi is minus 1 to the power n, and here is minus sign is there, minus of n pi into minus of 1 to the power n. This bracket complete, which is equal to, now माइनस माइनस हे काय होणार आहे प्लस होणार आहे. ठीक आहे, माइनस माइनस हे काय होणार आहे प्लस. मग इथे काय भेटणार आहे मला ब्रॅकेट मध्ये मल्टिप्लाय केल्यावर e टू द पॉवर माइनस a into n pi into minus 1 to the power n divided by a square plus n square pi square minus of e to the power a into n pi into minus 1 to the power n divided by a square plus n square pi square. Okay, now this n pi minus 1 to the power n, this a square plus n square pi square is again common in both the term. That's why taking out bracket outside common, we will get n pi minus 1 to the power n divided by a square plus n square pi square. In bracket we will get e to the power minus a minus of e to the power a. This is the value of bn. It's very simple. Now put the value of a naught, the value of an, and the value of bn in the expansion. Here we will get the Fourier series expansion of f of x is equal to e raised to ax in -1 to 1, which is very simple example is there. Okay, if you have any problem, then you can ask me anytime in comment box. This is very simple. With that, our fifth video is on the Fourier series is finished. So please watch carefully. If you have any problem, then ask me. Thank you for watching my video. Thank you.